All right, so we're talking about volume of revolution here. It goes along with area in the sense that you're still using the fundamental theorem of calculus to determine particular different things about different functions. So if y equals f of x is continuous on an interval, okay, from a to b, and the region bounded by the function and the x-axis is rotated 360 degrees, then the volume of the solid is given by this equation here. So basically you have a function, and the function itself and the x-axis, that space in between, you're basically taking that and rotating it around the x-axis continually to form a type of solid. And then you're actually going to determine what the volume of that solid is by using this formula right here. Very simple. It's pi times the integral from a to b of your function being squared. Yes, you square your function. So if your function is x squared, when you plug it in, it turns into x to the fourth. Okay? So what's that? Any questions on that? Straightforward. Plug it. This formula is on your reference sheet, okay? I know this one is. I don't know if area between two curves is, so somebody might want to look at that and confirm for me. All right, so going straight into the question, you do need to fill in the shaded region. It's going from 0 to ln4. This one we are going to do, I believe, with calculator, so go ahead and pull out your calculator. Nope, just kidding, not a calculator. But you will need your calculator for the other ones. So this diagram shows part of the graph of y equals e to the 1/4 x, the shaded region between the graph, and from 0 to ln4 is rotated 360 degrees about the x-axis. Part A says to write down the definite integral that represents the volume that is formed. Simple enough, you have to write down the equation. You basically have to plug it to the formula, starting with what? Pi. The integral from
0 to ln4.
So far, so good. What goes here?
E to the 1/4 x squared. Now we're just multiplying, so it's 1/2 x, right?
So then you actually want to go through and actually square it if it can be squared. So this is pi.
E to the 1/2.
0 ln4 e to the 1/2 x dx. And honestly, I suggest that you go all the way through with this step because what part B says the volume is equal to pi k, and you have to find the value of k. So simplify it because you know you're about to do it anyway.
Why is it 1/2?
Because
1/4 squared.
well, remember when you're with your exponents, whenever you have a power to a power, you multiply. See?
Hey, the math only goes up like geometry.
So here we go. It says the volume is equal to k pi. So you actually have to determine what is the definite integral for this, and then set it equal to k pi.
Or
So
can you just set it equal to just k because you can divide by the pi on the outside?
you can do that too. What's the antiderivative of e to the 1/2 x?
2e to the 1/2 x.
Very good. That is one of those. That is one of those. Remember, it's 1/a. Okay? You evaluate that from 0 to the ln4. When you evaluate this, what do you plug in? First.
B. ln4.
On the outside. So it's so far on the outside. So we have e ln of 1/2 ln4, and then 2e to the 0.
Wait, are we supposed to solve it? Oh,
Mhm.
okay.
Well, I'm plugging it in. After I simplify this, I am going to set it equal to k pi. So I do have the pi on the outside. Now, real quick, revisiting exponentials.
Isn't that just 4?
2
4.
It's going to,
It's just going to be 2e2, right?
2e to the second. So you're going to have pi on the outside. 2e. Remember, anything that's in the front can be moved where?
Multiply.
Exponent. You guys remember that from exponentials? ln do what?
E and L and E
They cancel out. So then what's 4 to the 1/2?
2.
2. So you basically have 2 times 2 minus, what's e to the 0 power?
1, 2.
So what's 2 times 2 minus 2?
2.
You have 2 pi. That equals k pi. What is k?
2.
2, 2.
2's. Question on this one. Let's look at the next one. You have another shady region that you have to fill in. From 1 to A. What you guys try to do this on your own. You should have set up the definite integral for the volume. So it should have been from 1 to A of the function 1 over the square root of x squared dx. Now when you square a fraction, let alone a square root, you square the top and the bottom. So then that turns into a 1 over x dx. That should have been part A. Yes?
Yes.
So then is it the volume of the solid form is 3 pi, find the value of A. So what is the antiderivative of 1 over x? ln of x. And do realize, guys, if it is a calculated type of problem, a non-calculated type of problem, it's going to be simple to an extent. It's nothing going to be like too crazy and have to wait. Okay? So when you plug it in, you'll have ln of
A
minus the ln of,
1.
and hopefully you remember from your days.
Ln 1 is 0.
Thank you. So you basically have pi ln a, that equals 3 pi. The pi's do what?
Cancel.
Ln of a equals 3.
So like
Solving.
the way that we do those odds is like e to the 30.
That's cancel out, and a equals e to the 3rd. And that's it.
Which is like, it's like 2.74 or something like that.
To the 3rd power.
So,
Questions?
no.
Bet money on it.
It is 20.0.
Alright, linear motion revisited. Are there any questions about volume? Volume is pretty straightforward. Unlike area where you have to make sure you have the curve on top, curve on the bottom, and at no point in time you have multiple curves across. Linear motion, remember that displacement is s of t, velocity, which is the derivative of displacement, and acceleration, which is the derivative of velocity, which is the second derivative of displacement. You guys have forgotten that, correct? Displacement function tells us the distance and direction of a particle is from an origin at any time t. So, the change in displacement from time 1 to time 2 is given by this function here. Velocity is displacement from t1 to t2. Okay? You can think of that as basically like the change in displacement is basically, of course, slope. So, everyone got that? Alright, now one concept that also goes along with linear motion, because of course we know that if we're given a velocity function, we have to find displacement, then we are going to do the antiderivative. But there's one concept that's not in derivatives that is with integration and linear motion. It's this whole idea of total distance traveled. So if velocity is given for a particle moving along the line, the total distance traveled by that particle between 2 time intervals is the absolute value of velocity from A to B, the integral from A to B. And of course, A represents time 1 and B represents time 2. So if they ever ask you to find the total distance traveled of an object, or how far the object has gone, total distance, you do the absolute value and still just do the antiderivative. So basically whatever you get, you just make it possible. Simple enough? Good. Let's look at these 2 examples. This one is going to be calculator. The velocity v in meters per second of a particle moving in a straight line is given by that function where t is time in seconds. It says find the acceleration of the particle at t equals 1. So what does that exactly mean here, Harrison? What does it mean to find the acceleration of the particle?
We gotta find the derivative. Yeah, the derivative and then plug in 1.
You have to take the derivative of velocity. So the derivative of velocity equals acceleration. What is the derivative of t squared minus 9?
2t.
2t. We are going to plug in 1 to find out that our acceleration at 1 is 2, give me my units, meters per second. So this right here, yes, derivative problems and integration problems can be embedded together, so just be aware of that, okay? Now, for B, it says the initial displacement of the particle is 12 meters. Find an expression for S, the displacement, in terms of T, okay? So, initial displacement means what? Who can tell me what initial displacement means? It is going to be antiderivative of velocity, but more specifically, you have initial displacement when it's 0. So basically, this is like indiscreetly giving you a point that you're going to plug in to find that C, that constant, 0, 12. Okay, so when time is 0, the particle is already 12 meters, I guess, from its origin. So if you're trying to find an expression for S, that means we're actually getting a full out equation. Yes?
Acceleration is
Yes, because it's already meters per second, so yes, second squared.
Good job, Brian. Catch.
So to find S, we are going to have to take the antiderivative of velocity. Okay? What is the antiderivative of velocity?
1/3 t to the third minus 9t plus, you want the answer?
Before we actually get to the final answer, what comes at the end?
Minus 9t.
Plus C. Okay? Because it's just the antiderivative right now. We do have to figure out the value of C, and to do that,
It's a negative 9.
we are going to have to find the value of C. So C is, how do we find C?
Plug in 0 for t equals 7.
Plug in 0 for T and 12 for S of T, and we find out that C is equal to what? Positive 12. So our answer to part B, when it says to find the equation for displacement, 1/3 T cubed minus 9T plus 12. Questions? Now, find the total distance traveled between times 2 seconds and 8 seconds. Remember, distance traveled is the integral from time 1 to time 2 of the absolute value of your velocity function. You could plug this into your calculator. You could do it by hand because it is, pretty simple numbers. Either way, you should still get the same answer. This is a calculator problem, so you can use your calculator. I'll let you choose, but you do need to get me the total distance traveled. So do that. Don't shut out your answer, but figure out the total distance traveled. All right, what do you get?
114.
This will be 119.
Whoa.
I calculated. Did you plug it in with the absolute value? That does make a difference. Use your calculator. So. That's the value. The integral, how do you do it here? Math. You go to 9. Just one more quick check. So everybody's calculator to do this. If it doesn't, you are going to have to type it in by hand. I am going to review this again. No. It'll pop up. FNINT. What do you type in first?
Function.
The function, whatever it is. Then what?
Comma.
Comma.
X. Comma. Lower bound.
sure that you guys do not forget about this, because like I said, you're not going to know what type of calculator you're going to get, okay? If you do not have your own personal one and you don't turn that one in to get cleared, who knows which one you're going to end up with. So, 2 to 8, it has to be the absolute value of your velocity function. Absolute value is located in the same place where all these other interesting functions are located. Math. Go over to number, and there's ABS for absolute value. You type in your velocity function, which was x squared minus 9. Of course, you do it with respect to x. And you get 119.3. You're allowed to do it by hand. By hand, the absolute value is something beyond this course. So, beyond. Hence why I was calculating wrong. Alright? So your answer is 119 meters. Let's look at number 6. You have a function. This one is non-calculated. This one is non-calculated. Okay? The velocity function is given for a particle moving along this figure. There's no equation associated with it, just the picture. You have to find the acceleration when t equals 3. Acceleration is what? It's the first derivative of velocity. Derivative means what? Slope. So in this case, we don't have a function, okay, which means to try to take the derivative of this using, you know, an equation or something, we don't have this. So you have to remember that derivative means slope.
You gotta find the slope with the
Old
school formula.
The old school slope formula, exactly. 3 lines right here along this line. So you're basically going to have to find the slope of this line. Old school slope. Don't say that, because you know the video picks up stuff. The typical thing that makes sense. All right, find the slope. Let's go. So again, you are looking for the slope. What is it?
2.
It is 2. It is 2. You have to write down the time intervals on which the particle is traveling to the right. This goes back to derivatives. When a particle is traveling to the right, that means that what? Not necessarily.
Greater than 0?
What's greater than 0?
The velocity.
Velocity is greater than 0. That's what it means to travel to the right. If it was traveling to the left, then it'll be less than 0. If a particle is speeding up, acceleration and velocity have the different signs. If it's the same as slowing down, or vice versa. For this problem, what are the time intervals in which the particle is traveling to the right?
2 to 10.
2 to 10. Because this is the graph of the derivative, so you're looking for the part where it is above the x-axis. All reviews of derivative. C is integration. You're trying to find the total distance traveled. You don't have an equation here, but you do need to take the antiderivative of the absolute value of velocity. What's another way to represent in words, just like how derivative means slope? How do you do that? What do you have to do to find the antiderivative of velocity?
Would be 2t. And then you take the derivative of that because.
Nope. Think about it. Distance traveled is the integral from A to B. Absolute value of velocity. What does this mean? That is the bounce. Huh?
There's 16 0.
It's from 0 to 16, yes. But like I said, just like derivative means slope, what does it mean to take the definite integral of something? This whole thing means to find the distance traveled, but it is the area underneath the curve. So derivative means slope, integration means the area underneath the curve, between the curve and the x-axis. So if you have to find the traveled is the absolute value of velocity. Means you have to find the area from 0 to 16 and take the absolute value of those numbers. That's what you have to do. So you need to notice that this is the very first thing that we did when we were doing definite integrals. You have a triangle from 0 to 2. You have another triangle from 2 to 10. And then you have a trapezoid from 10 to 16. You basically have to do 3 different areas. So you guys go ahead and do that. Find the area of each one of these. Take the absolute value of each one and add them together. All right. So you have your area of your triangle. This is a base of 2, a height of 4. So 1/2 base times height, which gives you 4. And technically, it's actually a negative here, but you have to take the absolute value, which is going to be a positive 4. For the other triangle, you have a base of 8 and a height of 4. 1/2 base times height is going to give you 16, plus the trapezoid is 1/2 the sum of your 2 bases. This is a total of 2. This up here is 6. We also get 8. Then you have to multiply that by your height. Your height is 2. Okay? Multiply those together. Divide by 2 and you get 8. Technically it's a negative 8 because your height is negative. But you take the absolute value of that to get a positive 8, and 4 plus 16 plus 8 is 28 meters.
You couldn't take like the absolute value at the name of adding them all together?
That would have been negative. No, because then you would end up with a negative 12 plus 16, which would be positive 4. Absolute value of that would have been.
So I have to do each one.
All right. The last 2, they are both calculator and they are on you. You have a total of 9 minutes to get it done.